On the morning of Saturday, November 18th, we witnessed the future of human spaceflight, and it was spectacular. This is the Starship flight test number 2. As the sun rose over the Gulf of Mexico, so too did humanity's best hope for a future among the stars. The most powerful flying machine ever created took flight for the second time and delivered everything we had anticipated, plus a little more. It's important to remember that the main goal of this second flight was to get the vehicle through to stage separation and test the new hot staging system. Everything past that would be a nice bonus. After scrubbing a Friday launch due to a faulty grid fin actuator, SpaceX crews worked through the night to destack the Starship and replace 3 of the electric motors that control the rotation of the Super Heavy booster's grid fins. One was confirmed broken, but 2 more were swapped out due to an abundance of caution. The vehicle was then restacked and prepped for launch. At the crack of dawn, ground systems at the Starbase launch pad were in full motion to prepare for propellant loading of the booster. This began at T-1 hour and 37 minutes from the expected 7 a.m. launch time. Everything was going smoothly and according to plan. And that trend continued straight through the pre-flight checklist up to T-minus 40 seconds. This is a planned hold for the Starship launch. Crews can pause the countdown at this point to give them extra time for final checks. The ship can be held at 40 seconds for up to half an hour. At the time of the hold, Starship is fully fueled, operating on its own internal power, and has been released from the hold-down clamps on the launch mount. After final pressurization was confirmed on the upper stage, the countdown resumed, and we are a go for launch. At T-minus 5 seconds, we can see water spraying out from the new flame diverter system. Then, just before the clock hits 0, we can see the first plume of fire from the Raptor engines as they quickly build up thrust. All 33 engines are running for about 5 seconds before we see the first movement of the ship. From here, it starts moving very quickly. By T plus 10 seconds, the tail of the booster has cleared the top of the launch tower, and the rocket is already traveling at 140 kilometers per hour. From the moment of liftoff, we can see the improvements that SpaceX has made to both the vehicle and the launch pad since the first Starship flight test back in April. The most obvious difference being that we can actually see the rocket as it leaves the pad. The first launch was covered by a gigantic cloud of rock, dust, smoke, and debris. This was not repeated on Flight 2. I've checked a few different camera angles, and I can't see any significant debris coming out from the launch pad this time around. The shockwave definitely sent a bunch of loose material flying. Everything at the launch site that wasn't bolted down probably went airborne, but I can't see any pieces of the ground being ejected like what happened before, so preliminary results indicate the showerhead worked as intended. Looking back to the Starship now, this is what a methane-burning rocket is supposed to look like. Perfectly clean, smooth, and consistent plume of fire coming straight down from the Super Heavy booster. We see none of the smoking, sputtering of flames that happened on flight number 1. All 33 engines are performing beautifully, and for the record, this is the first time that has happened. Even during ground testing, SpaceX never gets all 33 booster engines to perform through the entire test duration. As the Starship ascends, it's traveling straight and smooth right up until max Q. That's the point of greatest mechanical stress on the body of the rocket, and this happens right around T plus 1 minute and 5 seconds at a speed of 1,300 kilometers per hour and an altitude of 10 kilometers above sea level. Then, 90 seconds later, we get to the main event, stage separation. The furthest that any Starship has ever reached. Because we are doing hot staging, there is no main engine shutdown or MECO as we typically know it. Instead, most engines shut down, leaving the center 3 Raptors on the booster continuing to fight against gravity as the ship prepares for action. At this point, the Starship is going 5,600 kilometers per hour and is 69 kilometers above the ground. Now, a lot of stuff is going to happen very fast. The clamps holding the 2 stages of the rocket are released. The 6 engines on the ship ignite and the hot staging process is underway. As the ship pulls away, the remaining 3 booster engines will use their gimbal mechanisms to begin flipping the booster around 180 degrees so that the top is now pointed straight back down towards the ground. During the hot stage, we can see all of the flame and exhaust from the ship engines being diverted out through the side vents of that hot stage ring on the booster. The 3 center engines on the ship are using their gimbals to angle as far towards the outside as possible so that they are not blasting directly into the top dome of the booster. And here is where the first problems start to arise. When the booster starts to flip, we can see the first engine restart is already underway. Most of the 13 interruptors have relit, but some are still visibly dark. As the booster comes around, telemetry shows 4 engines out, only 2 of the center group are still running, plus 3 of the outer ring engines are down. They're all clustered together on one side, so we're starting to get asymmetrical thrust. By the time the flip is completed, the booster airspeed is down to around 4,700 kilometers per hour, so it sheds around 1,000 kilometers per hour of velocity through the flip maneuver. We can see that another booster engine is out now. It's opposite of the 3 failed engines, so this could be intentional to try and balance out the thrust, or it could be more error. At T plus 3 minutes 15 seconds, there is some kind of an event and multiple engines go down at once, bringing the failure count to 7 Raptors. We've now only got 4 of the mid-ring engines still running, and they're all clustered together, so highly asymmetrical thrust. 2 of the center group are still running. By T plus 3 minutes 18 seconds, all booster engines are out. At plus 3 minutes and 20 seconds, the booster itself explodes. This happens fast. It basically pops like a balloon at 90 kilometers in altitude and traveling at 3,800 kilometers per hour. This is the flight termination system taking the booster out of the air because it's gone way off course due to the engine malfunctions. This is exactly what it is supposed to do in this situation. So another massive improvement from flight number 1, the self-destruct worked. So what happened to the booster? It really does not seem to have been damaged by the hot staging event. I'd say it's more likely that during the flip there was an issue with tank pressure and fuel sloshing around. Obviously, no one's ever tried to flip such a gigantic fuel tank around in mid-air, so the fluid dynamics are totally unknown, but now SpaceX has significantly more data about it than they did before. This whole time, though, the ship stage has been well underway and is gaining velocity and altitude on its way to slightly less than orbit. The point of this flight test is to get the ship very close to orbital velocity, but keep it at a speed where it will naturally fall back down without the need for a deorbit burn. At this speed, the ship is still going to hit the atmosphere hard enough to stress test the heat shield tiles, if it makes it that far. As the ship continues to burn all 6 engines, we're hearing callouts from the ground crew that all systems are nominal. At T plus 4 minutes, we can see some interesting white specks appear on camera, either UFOs or debris from the booster catching the sunlight. At T plus 5 minutes, we hear the callout for ship trajectory nominal. At 6 minutes, we hear ship pressure nominal, so everything appears to be going very smoothly up there. Until we get to T plus 7 minutes 7 seconds, the ship is traveling at 17,000 kilometers per hour, it's 149 kilometers above sea level, and we see a plume of smoke visible on camera. At T plus 7 minutes 40 seconds, we see a second plume from the ship. It's now at 21,000 kilometers per hour, and telemetry shows all 6 engines are still firing. Altitude remains about the same 148 kilometers. By 7 minutes and 50 seconds, the plume is cleared, but we can only see a very faint light from the ship's engines. At 8 minutes 3 seconds, telemetry shows all engines cut off on the Starship. The vehicle is at just over 24,000 kilometers per hour. Then 2 seconds later, we see a small puff, followed quickly by a larger puff, and this marks the end of Ship 25. Flight termination kicked in very late into the second stage burn. We were only a few seconds away from second engine cutoff, and the coasting phase that would have taken the ship most of the way around the world to the Pacific Ocean. So what we saw here was probably about 80% successful. We only really missed out on 3 main events. 1, the return of the booster, so we didn't get a re-entry burn or a landing burn over the water. 2, we did not get a second engine cutoff on the ship, which is not a big deal. 3rd, we did not see the re-entry of the upper stage, which is a bummer because this is a massive unknown. No one has ever tried to bring anything that big back down from space before, and we still have no idea how Starship's heat shield tiles will perform under stress. You can already see from some still photos that a lot of the tiles fell off during launch, mostly along the weld lines, so the ship probably would have broken up anyway, but there's no way to know until we can actually get to that point in the flight. NASA Administrator Bill Nelson seemed pretty stoked about the results. He posted on X shortly after the launch, "Congrats to the teams who made progress on today's flight test. Spaceflight is a bold adventure demanding a can-do spirit and daring innovation. Today's test is an opportunity to learn, then fly again. Together, NASA and SpaceX will return humanity to the moon, Mars, and beyond." And that's probably the most important thing to remember. We are taking the first very small steps right now towards the most gigantic leap that humanity will make in our lifetime, sending people to live on the moon and eventually to Mars. This is not going to be easy, and there will be plenty of failures along the way. In terms of what comes next for SpaceX, well, likely we're going to be looking at another FAA mishap investigation for the Super Heavy booster. It accomplished more than we would have expected, but it still did malfunction and fly off course, so that needs to be looked into. But this will be more of a routine job and much less involved than the 420 launch investigation. Technically, SpaceX is still approved for up to 5 launches from Starbase in 2023, so will they try and take advantage of a December launch window? Depends on the condition of the ground systems. We know that the launch pad was not destroyed, but it could still be damaged, or at the very least, SpaceX probably discovered something that could be improved. We know that SpaceX has plans to upgrade the orbital tank farm at the launch site to enable faster propellant loading, so they'll probably want to do that before another launch attempt is made. We are also starting to see a lot of indications that SpaceX is getting ready to construct a second launch tower at Starbase, so maybe their energy gets diverted into that project for a little while. Either way, likely no more Starship launches for a few months. Late winter or spring 2024 would be a good guess. As for what the next flight of Starship might look like, well, they already have Booster 10 and Ship 28 pretty much ready to go, so the hardware is definitely not in question. As for the flight profile, do they try for a full orbit? Do they attempt a payload deployment? I'd say it's most likely that SpaceX will try the exact same flight profile next time around as they did on November 18th, because we still need to get that data about the upper stage, and that should probably be known before it goes all the way to orbital velocity or tries to carry anything into space. So stay tuned for our next video out on Wednesday when we go even deeper into the details and aftermath of the Starship test flight number 2.